What do you say? Okay, come on. Come on. Okay. I think I'm gonna have to stop for a little bit here and play with my cats. So, okay, we'll just leave this hanging, right, just like this. Yeah, I hear ya. Okay, Peanut's all happy now. He's on his way outside. Let's go with this one. .05. That was from pin 4. Just double check quickly. Make sure pin 4 is C21 .05. Right. Okay, another .05. Close look at all that and see what it looks like. Okay, first this one here. Looks good. This one here. Flex it a bit. Yeah, looks good. This one, I think it's okay. And down in here. Okay, let me wiggle that. Looks pretty good. Okay, this one here. So often I do this and doesn't look quite as good. It's solid though. I often do this off camera. This very careful checking of all the solder joints. I'm gonna do that one again. It looks solid, but it doesn't look like it really fused down onto the old solder. So I'm gonna give it. Oops! Wait a minute. Where'd it go? There it is. I'm sure that's good. Okay, well, those were the easy ones. Now, we gotta do the tough guys. So I think the red one down there is going to be easy. Comparatively, it's really this paper one that's a disaster here. You know, I gotta get a soldering iron down there. Wow. Isn't this difficult? It's just... Well, there's a line of sight right over the top of this, right down to it. We're back to the switch here. So we'll leave this as an option to remove the switch, get it out of the way. We won't do that right away because it introduces more and more problems. We try to go directly after this one. First, I'll disconnect it here, swing it out of the way. I'll pull this one out and replace this red one first. Now even leave this. Let's cut it out of there. Leave it. Let's leave it. Leave it for now. Cutters. Where's my cutters? There. I didn't test those other capacitors. Let's do that. We'll pop this one out and test them. 3 of them. Getting good results from the first one. Maybe I just kind of mentally decided not to look at the rest. So this is a Goodall. I never heard of that. A Goodall capacitor. 0.05. These are all 0.05s, aren't they? 0.05. Yeah. 0.05. Okay, let's go and test these guys out. Let's see what we end up with. Oh my gosh, I'm so tangled up here. Okay, there we go. The tripod is free. Free. Okay, you can see the gap. Good. We'll start with the other ones here. It's down to 50 volts. $50. That's very good. Not so good at 150. So again, just a bit of a tired guy. Now how about this one? This is made in Canada. Oh, this will be good. Aerovox. This will be just like new. Made in Canada. Okay. 50 volts. Look at that. It's a good Canadian capacitor. 150. 250. Still open. Okay, so this guy was good. You look at the construction of it. I mean, this is as rugged as can be. This material is really hard. There's no gapping around the leads. That's a toughie. And now we do another. No, this wasn't a Hunts. This is a. Oh wait, this is the Hunts. Here it is over here. The Goodall. It also looks to be in great shape. I'm not testing them for size because I think we can assume if they're not leaky, they will test okay for size. 50 volts, can you do it? Oh yeah. Well, it appeared to be this must be a smaller capacitor. See how quickly it charges? Yeah. Either that or this one is shot. 0.05. Hey, let's measure this one because that was reacting so fast. It was as if there's no capacity in here. 0.05. So it's I think it's 0.5. 0.05. On this scale. There we go. Can we find it here? Ooh, look at that. See that open up really wide? That's another indication of a really good capacitor. And where is it? 0.01. 0.05. 0.05. So lots of work to get these guys out, and they're turning out to be okay. Did I do this one? I don't think I did this. Did I do this? Let's do it again. So 0.05. I can't remember. 0.05, leak. Good, leak. Not so good. So, you know, again, when you look at this capacitor, this appears to be very well built, really well sealed. See, if we got up really close, you might see some gapping in the lead coming out. But it looks great. Not so great. Some of these capacitors, even if they're perfectly sealed and no moisture has entered them during their life, there will be some amount of moisture in them right from the start and some amount of undesirable chemical contamination. Some amount. You can't make them perfect. Nothing is pure in this world. And some of them, if the contamination is bad enough, they will just wear out internally. Wear out not being quite the right term for it, but okay. So some of those, pretty good. Some of them kind of okay, but again, I think they're in a very sensitive part of the radio where you don't want leaky capacitors. And all we're left with now is, well, I got to put in the new guy in here. Oh boy. Wow. I mean, you can almost swear that this is going to be a leaker here. My God. Well, let's put in the 0.05. Get that done. Looks pretty straightforward. Good. Now we're left with the last deadly capacitor. Maybe I separate it at the top, bend it out of the way, leave the lead continuous down below. Bring the new capacitor and hook the old lead while it's continuous, and I have some, you know, the lead basically is the capacitor at that point. I move the capacitor, I can move the lead, I can kind of work it, kind of get things in position. As for clamping it, like squeezing it with pliers, oh my gosh. You can hardly even see it, let alone work on it. And kind of lasso the lower wire on here, and then once everything is done, just cut this away. That's probably the best approach. It's a good starting approach anyway, because I still have the capacitor connected at the bottom. If I really get scared, I can just reconnect it at the top and run away. Lighting here. And I'm not going to be able to get really good camera shots on this, I'm sure. He says, realize I could do better with this other camera up here. Let's try that. right in the bottom right corner. There he is in there. So the idea is to take another capacitor, bend the leads appropriately to make it into a hook, send it way down in there and attempt to hook the back of this capacitor. The idea is the wires can't pull off the capacitors there, holding them. And then I somehow get my soldering iron down there and solder it. That's going to be a smoky mess. Okay, another possibility is just to rip this capacitor out. Just physically grab it and rip it out and leave behind whatever's left behind. Why would I want to do that? That's pretty uncontrolled. Don't think I want to do that. That's a deep breath. Okay, let's just try to... Whoops, camera guy got hung up there. Yeah, new location for the camera. What if I stuck it kind of up in here? I just kind of jam it up in here. In the radio. Well... No. Hold on here. Oh yeah, there we are. Excellent. Now I can really see the situation. Oh boy, looks easy now. And there's a red, orange right there. 22K right beside it. Okay, so the size of that one, we can read right on it, can we not? Something in millifarads. I can't read it. Let me see if I can read it with my eyeballs here. 0.0. I think it's 006. I think it's 006. It's part of the oscillator. Let's take a look at the schematic here and just see what we're dealing with here. Okay, so I said part of the oscillator could be... So one lead does go to ground. Does it? Does it? I don't know that. No, this is not... This capacitor is not going to ground. There's no way it's going to ground. So this is not this one. Not this one. Oh, could be this one. Ooh, could even be this one. 24 and 23. How big are they? 0.006. So I think 23 is the winner. Look at this one. And mold it. Wow, where is C24? No, let's not get hung up here. Let's stay on that topic. 0.006. All I have are 0.007s. Where is he going? 23. 23. So 23, would it be involved in the resonance of this? Would it have a factor? Would it be a factor? It's probably not. It's just feeding up, it's carrying the oscillator signal up to the mixer tube. So everything is going through here. Well, what's this one doing? So this is the tuning capacitor. So this one might be... Looks like it's the grid. So there's one grid. There's the other grid. Again, I don't really understand what they're doing here. So that doesn't really matter. So C24, I don't think it's up in this area because I only see one capacitor. 0.006 it's going to be. That's the winner. 0.006. 0.006 only have, well, I could do 0.005 or 0.007. What's going on here? I I got some that are actual 7s. Hey, wait a minute, here's a 6. 602. Isn't that a 0, 0, 6? Okay, hang on. Let's switch here to 006. Is it really? Bingo. Okay, that's good. We'll put in what was in and what is being asked for. Well, we're going to try anyway. So this is the plan. We go down with a hook and pull up. You make it a long hook here. I can get at the tail and kind of cross it over a little bit. This is a very light wire. I might be able to kind of tie it down in the back there. In the back. So let's just try modeling this a little bit. See what happens. I'm just bending the lead here. So it's going down, way down. I got to be able to get the hook around it. And then coming up, pulling tight. I should pull this capacitor up, so that'll give the lead. No, leave it down. Then when I pull up the, you know what? I can get it through the contact. I can get it through the, can I? Is that a hole? What is that? Well, it sure looks like there's a hole I can push this through. Oh, that would be great. Let's try that. Okay, change of plan. So just try feeling it through there now. And see if there really is a hole there. Trying to watch the camera, the image on my screen here. You know, it's not 3D, right? Right there, that's a hole. Isn't that a hole? You know, I think that is. I think that's a bunch of wire, kind of. What happened? I thought I had it right in there. I'm fooled by the depth here. Holy smokes. Yeah, I don't think that's a circle. I don't think that's a hole. Let's go back to the original plan. Original plan. Now, let's see if I can I can actually implement this time. Here we go. Going down. Going down to Lester's farm. Gonna join in a rock and roll band. Gotta get back to the land. Set my soul free. Of course, I got the music playing in my head too, you know. Really not getting at it here. So just like you, I can't see what I'm doing at the last minute. Here I can see now. Oh, come on. Oh, so close. Okay, so let's try this here. Okay, I got it. I got it around. Now how am I gonna? No, I didn't. No, I didn't. Now it's around, isn't it? No, it isn't. Holy smokes! That's got to be around. Now, how can I grab the other end of that wire? It's way the heck down there. Wow. Okay, hold it. Hold it. So in order for me to position myself, to get the tool down into that position, I have to step back. As soon as I step back, I can't see. More things you don't want to hear your surgeon say. Son of a gun. Is there some other angle I can come at this with? Can I get right through here? Oh my gosh, I can. No! The capacitors made an escape attempt. We caught him at the fence line. Here. Around. Okay, now hold tight. If I can get these down there. And then it's a fat chance I can grab that wire with these. Oh my gosh, I think did I do it? I can't even tell. I don't even know what I did there. What I did was I dropped it right to the bottom again. So is this a bad plan? Is that what's happening here? I haven't figured out how crummy an approach this is. That went nice. Okay, now what I'm going to do is I'm going to get a better grip on this capacitor up here. My fingers, okay. Got a good grip. Pliers. Come in there and get that guy. Oh my gosh. Really? You think it's going to work? Oh my god, I can't see a thing. Yeah. So this plan is starting to not work out very well. Okay, plan number 2 would be to get down there and cut that capacitor out and leave as much of the lead behind, and then just try to get this kind of hooked onto the lead, what's left of it. Because, you know, I can't, even if I got this on there, I wouldn't be able to solder it because the capacitor's in the way. Can I shove cutters through between the coils like I did that other tool? That's as far as I can get there. See, it's hungry, but it just can't get them. I'm kind of jamming it in among these coils here, which is not the best thing, because I could hit one of those light wires easily and just break it off and never even know it. Especially when you go to apply power to the tool, you lose sensitivity. You can't tell you're up against something. You want to come down like this. Now this will end up cutting the lead too short if I go that way. Oh my gosh. Not coming in this way. I'll cut anything. Come on, give me anything. The only way is down like this, or the rip it off thing, or the leave it there. The leave it there thing doesn't sound like a good idea. The rip it off thing doesn't sound any good either. It's going to damage the switch in the terminal. You've got to cut it. Oh, I just don't have the... I don't have it. How am I going to do it? So I have to get a little rougher with it. Let me see if I can put the capacitor into a little bit of a better spot. Uh-oh, computer's running low on storage space, so I'm not going to let this happen again. I'm going to stop right here and fix that. Okay, back in business again. Now, I think I need to take a different approach because I'm not getting anywhere with what I'm doing, so I'm going to try and make the connection, I can't quite see it, up here. The other end anyway, I'll connect it. That'll stabilize the capacitor, and then I'll work it down towards the other connection. Oh boy, it just doesn't look good. It does not look good. And I got to get that capacitor out of there. And I'm thinking now I'm going to cut the capacitor in half in order to tip it so I can cut the wire properly. So to do that, where's those big... I mean, if I can cut the back of a stove, surely I can cut a capacitor right too with these guys here. Oh, it's just the ugliest thing. You know what? This isn't going to work. They're not going to be able to get at it here. Never tried cutting a capacitor right through either. Oh my gosh. What a dumb situation. Let me yank on it and pull it up a bit. I pulled right on that terminal when I did that, didn't I? Like, I made it more difficult. It's more difficult. I gotta sink this down. Just so I can cut the wire at the other end and maintain its length. Oh, that's not working either. Okay, let's go with this. Totally opposite. Let's go down here. Back where you came from. You know what? That's better. That's better. I think I can get it out with a soldering iron and everything, just like that. Okay, let's not cut it out just yet. Let's see if we can hook. And can we do the hook thing? Can we do it and see what we're doing? Oh, there we go. Another escape attempt by that. Oh, this is a good one. He's trying to hide. There, got him. He didn't make it. Ah, careful. So that's exactly when you get hooked on the light wires down there and yank them off and not know it. You don't want that to happen. Once more. Down we go. Okay. Oh. Right there. Right there. Now, how about these... I've got some tools to help with soldering. What did I... Here it is. Wow. I'm lucky I found this. Now, can we get in there? Can we even see? Can I see? I can see. You can't see. I can see. Can't do anything about it, though. This is really the wrong way. This is really the wrong way. Let's go the other way. If we can. Down in. Come on, a little further. There. Excellent. Okay. Now. Hey, I'm cooking with gas now. See if I can bend that wire. Barely got a grip on this thing. Okay. I can't see. Coming in. You can see why when one surgeon figures out how to approach a surgery, it kind of becomes the standard approach for everybody, because figuring out how to do this stuff in a person's body must be just horrifying, really. I would think. Now I've got this really messed up here. There we go. I'm getting it hung up on other terminals. Out there. That's where I want it. Right there. Right there. Right there. Hold still. Nobody move. It's better. Grab that. Okay, I'm going to lose grip. Get it here. Maybe if I just, let me see if I can stabilize the capacitor in its position here. I'm bending the other lead around stuff to kind of just lock it into position, so I'm not holding it. There, that's better. Now, let's see if, no, don't do that. And then as usual, I can only see with one eye, of course, so I've got no 3D depth perception here. Ooh, what just happened there? I bent the wire way off into the wrong area. Let's try some pliers. Arrgh! This light is just driving me batty. Yeah, my patience is running out. We're at the end of patience here. So it might just motivate me enough to take a little risk and win. Oh, so now it's tucked right up behind the capacitor. The lead is. Ah! Down. Let's get other pliers. What are you looking at here? There we go. This is the right angle. I don't think I did anything. If I could solder it like that, that'd be great, but there's no way to solder it like that. Guess what's interfering? That switch is preventing me from putting the pliers exactly where I need them. That expander switch. Because I'm not seeing well enough. So I think you're looking at one of the reasons why people won't be going to Mars. The reason is the equipment that they would have to rely on for a couple of years is going to have failures in it. And how in the heck are they going to deal with that? How in the heck? Why is anybody even thinking about going to Mars? What a waste. That's a waste. You know, and I'm pro space exploration, but Mars? Why don't we just go see what's happening on the moon? Focus on that for a decade or two. See, the first time they went to the moon, the only reason they went was for political, societal motivation reasons. They didn't actually go there for any good reason. Really. I guess you could say, well, okay, maybe that is a good reason. Okay, certainly motivated Americans and the rest of the world to pick up their game. And, you know, people are going to the moon. Surely I can do something here on Earth that's better. Maybe I get through here now and get a grip of it. Oh yeah, look at that. Now we're starting to cook. Ah, good. I've got a really good control over my my pliers here. Okay, now remember, little wires in there somewhere. Little hidden wire. Oh, look at that! I actually did it. Okay, we've made the connection here. I actually did it. Now, the question is, did I solder that now and then try to cut the other one after? I think the answer is yes. Okay, so the soldering iron is off and cold. Let's practice. I'm going down. Once again, I won't sing the song this time though. Okay. Is it possible to get through the coils? No. There's no hope of that. The only angle of approach is basically the camera shot you're looking through. I think I can fiddle it. I think I can fiddle around in there, but I'm not going to be able to do it with these cameras, I don't think. Hey, maybe I can put this over here. What do you think of that? Don't think much of it. Can't see clearly from that point. It's really over here, but this is a... Oh, that's helpful. Okay, let me get this camera set up here, because that's going to help. So I'm just bringing in my camera stand here, my camera crane. Thought I had a really good angle on it. Kind of like that. That's about as good as it's going to get, right there. So what you're seeing there is the bent lead from the new capacitor. And you see the old capacitor lead disappearing into a little cover, I think. A little piece of cover. So, I think I can solder that like that. Okay, I see right where they're in contact. It's actually not that bad down there. If I could squeeze that just a wee bit more, or pull it tighter, maybe just a little bit better off. No. So I got my face right up against the microphone here. I am watching on my big screen as I try to do this. Come on, camera, don't sink on me now. Don't think I'm getting it much tighter. You can hear my pliers dragging over the top of the wires, the coils. No. Well, should we try soldering that? I think there's plenty of sort of close contact in there. Wow. I have to get a soldering iron down there. Oh, that's good. That's good. I can see clearly. Once I put the soldering iron in there, I won't be able to see clearly. Okay. Cold soldering iron. Running right into the... So as soon as I get in the area, I just completely block the view. Now, can I see? Is there a sneaky way to see? There's a sneaky way to see this. Let's go down here. Let's see if we can't use the sneaky way. Sneaky way would be right down through these. A little more this way. Okay. We'll just sharpen the focus here so it's right on the connection. Just missing it. And a little more lighting. Just missing the camera angle slightly. It doesn't look like there's anything there to solder. Who's dinging? What just dinged? Oh, over here. Okay, no problem. One more attempt at squeezing. No, can't do it. We're going to have to try soldering it as it stands. Now, I'm liable to bump the camera. So, oh, Camera's already been pre-bumped. Right in there. Okay, so the solder can come in through here, I think. Wow. This is going to be really tough. Okay, solder there. Sort of. Soldering iron here. Sort of. Oh my gosh, if I manage to do this, it's going to be a miracle. Soldering iron not reaching those guys. He's not getting down there. It's interfered with. Come on, we're so close. Okay, so close-up camera is not going to help at this point. Flip this guy here. Okay. Oh boy. We gotta take this switch out. I need the angle. It's a little loose, isn't it? This little switch will be a topic at some point, and what to do about it. Is there enough wire to back it right out of here? Hello? What are you doing back here? Didn't Mom let you out? It's a bit of a forcing, but there we are. Let me put these back on here. Yeah. Hello. Yes, my cat speaks English. He really does. Peanut. How many words in English do you know? Oh, how rude. It's you again. Speak some English to us. Out. Saying out. That's a real cry. I gotta go and deal with my cat. He comes first. Don't ya? Okay, that short break has made me rethink this again. I should really cut this old capacitor out of there, I think, because I'm going to get the new one in position, and it's just going to be that much harder to try to cut the old one out. And I don't want it hanging there half disconnected, because I think it might be a little bit of an antenna at that point. So I've got the new one kind of half in there. Just going to throw away all that effort. And I'll just move it off to the side, and maybe it'll stay. Stick it over there. You know what, I'm going to go in there and try to cut this lead on the old one, and I'm going to end up cutting the new one here too. It's a hard breaker, but it's got to come out again. Oh boy, what's going on there? Well, you know what's going on there? That's a great... Watch out. I'm going to scratch these coils here. That's actually a great position to solder it. That's actually pretty good. Just grab this. No, didn't work. I have to stabilize the rest of the. I'm working right on top of all these coils now. It's not going to get any better than that. It's not going to get any better. Let's see if we can solder it now. Put the switch out of the way. Oh boy. Better lighting. Okay, soldering iron will go right there. Okay, baby. Solder on there. Give me lots of solder. Whew. I think I may have done it. I think I may have done it. Let's see if we can get it on this camera here. Check it. Way down there. Okay, I can wiggle the end of the other end of the capacitor here. We'll watch. No, not soldered. Not soldered at all. Okay, so I'm pretty sure I didn't hold the soldering iron on there long enough. I think that's really the problem here. Throw a little more solder right on the end of it. Did I get there? I can't see a thing. What about on the camera? Oh, I can almost see it on the camera. I don't think any solder flowed there. I don't think I succeeded at all. Let's see what happened here. Oh, maybe. No, not at all. Not at all. Okay. It's just from lack of heating, I think. So I wonder if I get the cutters in there right now and nip off the top of that. You know what? That'll free up the new capacitor lead to fall off. And the whole idea was it can't fall off with that capacitor there. Wow, it's so close. Come on, let's try soldering it again. It's right where it needs to be. It's just falling right into position here. Where is it? It's way down there. Right there. Right there. Okay, on the solder. This is my best chance yet. So I have to swing this camera kind of out of the way here. I'm afraid it's still in the way. I'm just gonna bash my way through it here. Right on the money. Solder irons are right on the money. Solder's going on. Yeah, that's got it, I'm sure. I'm so sure I'm whispering. It's not exactly a full-bodied statement, is it? Okay, now we're going to grab this. See what happens in there. It's as loose as can be. I thought I had it for sure. So again, okay, I know what it is. I'm not waiting long enough for the heat to transfer. Okay, one more time. Get a little extra solder. Stick it on soldering iron. I don't normally pump up your soldering iron tip with solder before soldering, but sometimes it's really helpful. Oh, this just can't go in here. Okay, camera gotta go again. And this time I can't see as clearly. Not that it helped last time. Okay, leaving the solder there. Ah! There. Just waiting now. Patiently waiting. So what I saw was the original capacitor suddenly came loose. So that tells me I melted all the solder. That tells me there's a good chance this guy is stiffened up. He's a soldered. He is soldered. Sort of. That's good enough for now. Good for now. And I got a nice clear shot at cutting the old lead off. Okay, let's go at it here. Clear shot. Right in there. Gone. Feeling of success is coming here. There he is. 0.006 Sprague. So this is probably an example of original Sprague foil. So you see this dark band that's mounted on all these older capacitors. So this is telling you that this lead is connected to the foil sheet inside here. That is the one that wraps around the outside, the very outside. So that's a bit of like a shielding, if you like. So the tendency is you want to hook this end to the low impedance part of the circuit, usually right to the chassis or something like that, so what's going on. But unfortunately, all the new capacitors, they don't mark the outside foil end at all. And I just kind of ignored it. And it's pretty easy to determine the outside end, but I don't think it's quite as critical. So, okay, now we got to tip that capacitor up into position here. It's kind of, it's right here. I want to drag the lead, you know, over those coils. There we go. That was easy. And now it's just headed right here. Easy, easy peasy. Heading right here. I'm gonna scratch up the old wire here. Okay. Round it. There. You kind of have to know your tools. Have to have a good feel for what all these tools can do. So I've been doing this for years and years. Can you believe it? From the time I was a kid. I've been fiddling with pliers, so that's why I see the skill. That's why I'm demonstrating this unbelievable skill here. On here. I don't want that piece to go flying. Not in there. See, I'm jerking around because I'm rushing, I'm trying to get done. And in the end, it just slows you down, doesn't it? Helps you make mistakes. The rushing around then leads to more frustration. That's why if you get there, it's time for a break. That's why when my cats show up, I'm actually happy to go and spend a little time with them and decompress. Okay, well, it's unbelievable, but I think I've actually done it. I think we're good to, I think it's time to test this guy out and see if it still works. They're all gone. It's much neater looking than it was, that's for sure. It's a far better look to it. Interesting enough though, in the photograph that I popped up on the screen earlier, you could see down in here and you couldn't see any capacitors. Oh well. Okay, I'm so impressed. I'm self-impressed with that. That sure looked impossible when I started. Really, right from the first time I saw down in there, I said to myself, oh my god, that's not a place you want to go. But I also knew that sooner or later I'd be forced into it. Kind of knew that. We're going to start this thing up. And, you gotta make boo. Okay, gotta hook up the audio. Just leave the camera running here. Hook up the audio. Yellow is the hot, green is the not hot. Connect these on the volume control, yellow, the hot on the slider, and the green on the red, green on the red, green on the red. Of course, you know there's no such thing as color. Not in reality. We don't see color. There's no color to be seen. It's all a complete contrivance of our brains. No such thing as color. There's no such thing as sound either, by the way. Okay, this is on. It's connected to the phono cord. The levels are down over here. My headphones ready. Antenna is connected. No, it isn't. It's been pulled out. Let me reconnect. I'm not sure what we're going to hear. I don't even know what band we're on anymore. We're definitely on a band. Volume down. Any other crazy situation here? Let's just peek in the back. Anything crazy going on? Oh yes, there's craziness back there. Looney Town. I need to take off my capacitor markers because I've got these pretty well noted in my head. Now that clip lead actually wasn't connected to anything electrical, but the fact it was in there and forgot about it, that's not so good. Okay. I think we're ready. So we're going to do this. Whoa! Just 5 million wires here. I'm going to do this with the dim bulbs. I did a lot of capacitor work. We're going to make sure we're starting with just one. Won't be so dim. And everything else is ready to go. Right? Right. Okay. Armed, and now we're going to be dangerous. Let me get behind the camera here, where it's safer. There we go. And the light comes on and dims normally. These lights are on normal. Everything's normal. I'm not working in the, did not do work in the power supply as such. Hey, it'd be interesting to see if those resistors get hot. Yeah, that's what this is all about. Even though I really doubt. Really doubt that's going to have helped. There's that weird sound. Okay, so this coil is just singing a big tune here. Why is this guy just going to town? You know, that suggests a heavy current going through it. That's the suggestion. Oh, you can hear it very clearly in the microphone here. Why is this so echoey? Why is this so echoey? Oh well, not to worry about that. At this point, I had my headphones on, that's why I'm reacting. I'm hearing what's coming through the microphones, which I don't normally listen to. Okay, let's turn up the volumes. So first, on the audio side over here, a little bit here. Just a faint hum when I get it right up. Down there. Because the volume's not turned up on the radio, we'll now turn up the radio. Oh, that's nice. I like that. Let's tune it a little bit. I have no idea what band I'm on here. I think it's the broadcast band. Something happening there. Going quiet. Let's see if I can sort out the band. Sort out the band. I just shut the volume off. So we know that this is, the way this works is, okay, so if that's long wave, then the next setting is this one. Oh, that only makes noise on this band setting. Let's go further. Okay. Next band. Oh, volume. Listen, we should hear this. We should hear some of this. I don't hear a thing. Oh. There we go. Next band. Up the volume. Uh-oh. Oh, that's a really quiet one there. Careful. Man your volume controls. Everybody, man the volume controls. So that was shortwave. This is AM broadcast. That thing is going only on broadcast. And long wave? No. So what's going on with the broadcast band here? That's doing that. Hey, how about those resistors? Hey, how about them? You know, actually, I think what I'm hearing is a slight bit of feedback out of my headphones and into my microphones. I think that's what I'm hearing here. Move this very carefully. Switched on. Oh, I can't move it. What's happening? There we go. Okay. You can see those resistors. They look hot. They look hot. Where's my hot guy? Here he is. Okay, so we're gonna employ that. Last time I used this, I did a terrible job. I didn't look up at the screen and see that this was completely washed out. This time I'll be a little more careful. So we're set top temperature 80. That's a little high. Let's just bring it down to 70. So I'm looking right at something that's 70, and you know what that is? That's not a light bulb down here. It just happens to be on the screen. The lower temperature is 20. That's okay. You ready? Let's go looking for hot stuff. we're going to find it. So that is that. And that temperature is only, well, it's up around there. Not quite 50. This one up here, I don't think it's as hot. 56. Wow, these were measuring at 75, 70, weren't they? This is the really hot one. 50. So you know what? These are cooler, I think. 65. It was 75 before. I think some benefits have come here. Oh, you know, I twisted this switch up in here and never really paid attention to what happened at the back of it. So I turned this on without ensuring that there wasn't something stupid going on. I think it's okay. It looks okay. And nothing else has gotten hot in the meantime. No surprises here. Just these ones down here. Now these are really not very hot. 30. Oh, you can't even see what I'm doing here. Just checking these big high wattage ones I put in earlier, and they're pretty cool. 34. Really, it's not bad at all. 34 is not much above room temperature. Room temperature is about 21 in here today. Okay, so we seem to have had some partial success with dropping down the temperature of these two resistors. Not a dramatic improvement. They still look shiny and kind of melty to me. Hey, stop looking down there now. I'm up here now. I get a shock doing this. Yeah. See, I just took it right off. It's soft for sure. It's not quite as liquidy as it was. So yeah, definitely. Temperature's down. Well, that's something. You know, there still are old molded capacitors all over the place in here. Up here, like there's lots. In terms of these overheating resistors, the next thing I think to really consider, especially with this one, unless I'm wrong, all this one can carry really is, not all, but 90% of what's going through it is the screen current from this tube. Screen current extra high, we can kind of come at it from this point of view that there's something wrong causing a high screen current. What could do that? Other electrode voltages not correct. Too high a B+. I think it's too high a B+. And now that I've said that, let's take a reading. I gotta remind myself what the B+ is in here. I'm gonna pick it off down here. Maybe right here. So it's 320 there, and if I pick it off of a tube, which tube do I know is, so it's pin 4, isn't it? 4? I cannot see. Pin 4, 1, 2, 3, 4. I think, I don't think this is right. Let's see what we get here. This is the end of this big resistor. 90. Oh, yeah, you can see that. 90. Really? 90. Oh, don't scare me like that. And over here. Oh. Negative lead fell off the radio here. Let's try that again. What am I doing? I'm doing this. So there's all the B plus, and on the other side here is 90. That's 200 volts dropping on this thing. That's 90 into this tube. That tube is the third tube in the radio. Third tube in the radio. I'm now going to take a quick peek at the voltage chart. So this is the fourth tube. 90 on prong 4. How do you like that? I like it. And then prong 3 should have 270 as the plate voltage. 270 and 90, 265. So none of these are close. The prong 4, and of course these are all pretty much connected together, so the voltage can't be too far different. So there we go. So let's try this prong 3, 270. Good old prong 3. So prong 3, I think, is this one here. Maybe not. Okay, I'm gonna have to ground my hand here, which I don't like doing. Huh? You know what? That's not 3. That's like, this is 3. 300. It's supposed to be 260 something. And I think this is all stemming from the too powerful. Hey, what happened to that sound? Listen to that sound. It disappears. I'm going to guess what we're hearing is an oscillation in that transformer. That's not a it's this transformer. It's not, it's not a, it's come from another radio and stuck in here. It's not exactly the right coil. It could be it has some kind of weird resonance in it and it's oscillating away, and that's what we're hearing. And what we're hearing is not exactly the oscillation, but it's metal or wires shaking in there at resonance points that relate to the oscillating frequency. Anybody get that? Anybody get that? So it could be oscillating way beyond your hearing, but that is still audible because of the because of what I said. Okay, I make this stuff up all the time. Well, I think generally speaking, that was good. Getting a little lower temperature, probably a great improvement in the front end. I'd be stunned if it didn't really improve it. We still have more questionable capacitors. These are more on the audio output side of things, so I'm not so concerned about those. But certainly up in the top here are more capacitors, probably related to the front end of the radio. It's probably worth changing all these out, and because we can't know if they're good until I remove them and test them. We can't know. These are pretty easy to do too, so I shouldn't really hesitate. The owner's desire is to do the least possible. I think in this case, given what I've seen with the various capacitors that are coming out of here, inconsistent capacitors coming out of here, it's probably best just to get rid of all of these, and put in brand new capacitors. So I wanted to check the temperature again. Where'd he go? It's been running for a little while. Then this is all 60 now. So this is running also with reduced supply voltage. It's 100 volts. If I put it to 120, they're just going to get hotter. So more to do with these. And again, on the basis of I'm not really sure why they're overheating, I just change these capacitors and see if it helps. This radio will be good to go for decades after I'm done with it. That's what I hope now. Okay, well, thanks a lot for watching this crazy long video, and we'll see you tomorrow. It's lunchtime here. Bye.